In a world where air superiority means national security, the United States is already looking beyond tomorrow's battlefield. While the public's attention remains fixed on the F-35 and the upcoming 6th generation fighters, something far more revolutionary is taking shape in classified facilities across America. The Pentagon has initiated development of what military experts are calling a game-changing 7th generation fighter jet, an aircraft so advanced that it could redefine warfare in ways we can barely comprehend. Imagine an aircraft capable of hypersonic speeds, traveling to the edge of space, wielding laser weapons, and operating without a human pilot. This isn't science fiction. It's the future of American air power. And according to defense insiders, this future might be closer than anyone outside classified circles realizes. The United States Air Force is secretly developing what could become the world's most fearsome fighter jet, one that will ensure American dominance of the skies well into the second half of this century. What we're witnessing isn't just an upgrade. It's a complete reimagining of what an aircraft can be. If you agree that America needs to maintain air superiority, type yes in the comments. To understand the significance of a 7th generation fighter, we need to establish where we stand today. The evolution of fighter jets has progressed through distinct generations, each representing significant technological leaps. The first generation began in 1943 with the Messerschmitt Me 262, the world's first operational jet fighter. These early jets featured straight wings and flew at subsonic speeds. Second-generation fighters emerged in the 1950s, introducing supersonic capabilities and radar systems. The legendary F-86 Sabre and MiG-15, which dominated the Korean War skies, exemplify this era. The 1960s brought third-generation multi-purpose fighter bombers like the F-4 Phantom, used extensively during the Vietnam War. Fourth-generation fighters arrived between 1974 and 1990, featuring advanced avionics and high maneuverability. The F-14, F-15, and F-16 represented this generation, with many still serving today. The current cutting edge is the 5th generation, represented by the F-22 Raptor and F-35 Lightning II. These aircraft introduced revolutionary stealth technology, supercruise capabilities, and advanced sensor fusion. Now, the Air Force is developing 6th generation fighters under the Next Generation Air Dominance program. While still classified, this program has already produced flying prototypes, as confirmed by former Air Force Acquisition Chief Will Roper in 2020, who stated, "We've already built and flown a full-scale flight demonstrator in the real world, and we broke records in doing it." But even as the 6th generation takes shape, Pentagon planners are already looking beyond, conceptualizing the 7th generation of air dominance, aircraft that will likely enter service in the 2040 and 2050. Perhaps the most revolutionary aspect of the envisioned 7th generation fighter is its projected speed. While today's fastest fighters top out around Mach 2.5, defense analysts believe 7th generation aircraft will be truly hypersonic, capable of sustained flight at Mach 5 or higher. This isn't just about bragging rights. Hypersonic speed delivers game-changing tactical advantages. At Mach 5, a fighter could traverse the continental United States in under 30 minutes. Such speed makes the aircraft nearly impossible to intercept with current anti-aircraft systems. By the time defensive systems detect the approaching fighter, it's already completed its mission. Furthermore, hypersonic speed enables access to near-space altitudes, effectively blurring the line between atmospheric and space operations. This creates entirely new mission possibilities that current fighters simply cannot perform. The challenge, of course, is developing materials and cooling systems capable of withstanding the extreme temperatures generated at such speeds. Conventional aircraft materials would simply melt. This is where breakthroughs in advanced manufacturing and thermal management will prove crucial. Defense contractors are exploring revolutionary cooling technologies and heat-resistant materials that could make manned hypersonic flight possible. If these challenges prove insurmountable for human pilots, the 7th generation might be entirely unmanned, a possibility that aligns with broader Pentagon initiatives to develop autonomous combat systems. One of the most fascinating aspects of 7th generation fighter development is the aircraft's potential space capabilities. Defense analysts believe these fighters will operate in what's called near space, altitudes between 65,000 and 330,000 feet, where traditional aircraft cannot function but satellites typically don't orbit. This capability would revolutionize air warfare in several ways. First, it would enable unprecedented surveillance capabilities. From near-space altitudes, a seventh-generation fighter could observe vast stretches of enemy territory without ever crossing borders. Second, it creates new possibilities for missile defense. A laser-equipped fighter operating at the edge of space could potentially track and destroy enemy ICBMs during their mid-course phase when they're most vulnerable. The Missile Defense Agency is already working on the power-scaling technologies needed to burn a hole through the metal of an enemy ICBM. Third, space capabilities would position these aircraft as potential counterspace weapons. With China and Russia actively developing anti-satellite capabilities, a responsive counterspace platform becomes increasingly crucial for national security. Pentagon officials have reluctantly acknowledged that space has become a contested military domain. As one defense analyst stated in recent reports, as much as the Pentagon hoped space would remain a sanctuary for collaborative, multinational exploration, the domain has now long since been weaponized by U.S. rivals. The seventh-generation fighter would ensure American forces can respond to threats in this critical domain, maintaining the strategic advantages that space-based assets provide. Perhaps the most futuristic aspect of seventh-generation fighters is their projected weaponry. While missiles have dominated air combat since the 1950s, directed energy weapons, specifically high-energy lasers, are expected to become primary armaments for these advanced aircraft. The Air Force Research Laboratory has made significant strides in miniaturizing power sources sufficient for tactical lasers. These weapons offer several advantages over conventional munitions. They travel at the speed of light, making them impossible to evade once fired. They have potentially unlimited ammunition as long as power is available. And they can be precisely calibrated for different effects, from temporarily disabling sensors to completely destroying targets. Laser weapons would be particularly effective against enemy missiles, potentially enabling these fighters to serve as airborne missile defense platforms. Combined with hypersonic speed and near-space capabilities, a laser-armed seventh-generation fighter could position itself to intercept enemy ICBMs or hypersonic weapons during their most vulnerable flight phases. Beyond lasers, the seventh generation is expected to deploy advanced hypersonic missiles of its own. These weapons would combine the aircraft's already formidable speed with standoff capability, allowing it to strike heavily defended targets without entering the most dangerous threat envelopes. Perhaps the most transformative aspect of seventh-generation fighters won't be visible from the outside. It's the revolutionary artificial intelligence systems expected to control these aircraft. While fifth-generation fighters like the F-35 feature advanced computer assistance, seventh-generation aircraft will likely feature fully autonomous capability. The reasons are both practical and tactical. From a practical standpoint, the physiological demands of hypersonic flight may simply exceed human tolerance, particularly during complex combat maneuvers. The G-forces and heat generated at such speeds could render human pilots unconscious or worse. Tactically, AI pilots can process information and react at speeds impossible for humans. In 2020, the Defense Advanced Research Projects Agency, DARPA, conducted an AI versus human dogfight simulation in which the AI defeated a highly trained F-16 pilot in every engagement. The AI could make perfect calculations and execute maneuvers without concern for G-force limitations. However, military planners recognize that human judgment remains essential for certain aspects of combat, particularly when complex ethical decisions are required. This suggests seventh-generation fighters might operate in mixed formations, with human pilots commanding squadrons of autonomous aircraft, similar to the loyal wingman concept already being tested with current fighters. The Air Force's Combat Collaborative Aircraft program, which aims to pair crewed fighters with autonomous drones, provides a glimpse of this future. By the 2040s, this concept will likely evolve into fully integrated AI-human teams, with the most dangerous missions assigned to autonomous platforms. Building these revolutionary aircraft will require equally revolutionary manufacturing techniques. Today's advanced fighters already utilize 3D printing for certain components, but 7th-generation aircraft are expected to leverage what some engineers are calling 4D printing. Unlike conventional manufacturing or even current 3D printing, 4D printing creates materials that can change their properties, or even self-assemble when exposed to certain stimuli like heat, moisture, or light. This could enable aircraft components that adapt to different flight conditions, expanding or contracting based on temperature or pressure, for instance. Beyond 4D printing, the 7th-generation development program is exploring digital engineering and manufacturing approaches that could fundamentally change how military aircraft are produced. Former Air Force Acquisition Chief Will Roper introduced the concept of a digital century series, an approach that uses digital design tools to rapidly develop and produce limited runs of cutting-edge aircraft rather than committing to massive production numbers of a single design. This approach would allow the Air Force to continuously incorporate new technologies rather than waiting decades between fighter generations. As Roper explained in 2020, "I don't think it's smart thinking to build one and only one aircraft that has to be dominant for all missions in all cases all the time. Digital engineering allows us to build different kinds of airplanes." This manufacturing revolution could also open the door to new aerospace companies entering the military market. For decades, fighter development has been dominated by a handful of prime contractors. Digital design and manufacturing might enable innovative companies from the commercial sector to compete for military contracts. Another capability expected in 7th-generation fighters is vertical takeoff and landing, VTOL. While not new technology, the Harrier jump jet pioneered this in the 1960s. Advanced VTOL capabilities would solve critical vulnerability problems for forward-deployed aircraft. In potential conflicts with near-peer adversaries like China, conventional runways would become primary targets. As military analysts have noted, Chinese ballistic missiles could target American bases in places like Japan or Guam, potentially grounding conventional aircraft at the conflict's outset. A 7th-generation fighter with VTOL capability could operate from unprepared locations, hidden positions, or even ships not designed as aircraft carriers. This distributed operations concept would make it virtually impossible for adversaries to eliminate America's air power with preemptive strikes. DARPA's Advanced Aircraft Infrastructure-less Launch and Recovery Ancillary Program offers early insight into this capability. The program aims to develop experimental vertical takeoff and landing aircraft capable of operating from aircraft carriers and austere locations. Combined with autonomous operation, VTOL capability would enable truly distributed air operations, with fighters dispersed across vast areas rather than concentrated at vulnerable air bases. While stealth technology revolutionized air warfare with the F-117 Nighthawk and subsequent aircraft, 7th-generation fighters will take this concept to unprecedented levels. Current stealth aircraft have significantly reduced radar cross-sections compared to conventional fighters, but they're not truly invisible. 7th-generation stealth is expected to be so advanced that these aircraft would be practically undetectable by any existing or projected sensor systems. One approach involves flying wing designs similar to the B-21 Raider bomber, which eliminate vertical surfaces that create radar returns. Beyond shape, advanced materials that can actively absorb radar energy rather than merely deflecting it will further reduce detectability. Some research suggests metamaterials, artificially engineered substances with properties not found in nature, could potentially bend electromagnetic waves around an aircraft, similar to theoretical invisibility cloaks. The 7th generation might also feature active stealth systems that can adaptively counter specific detection methods in real time. Rather than relying solely on passive stealth features, these aircraft could analyze incoming electromagnetic energy and generate precisely tailored countermeasures. Combined with hypersonic speed and autonomous operation, this advanced stealth would make 7th generation fighters nearly impossible to target with conventional air defense systems. While a fully operational 7th generation fighter might seem distant, the foundational technologies are already in development. The Pentagon typically works 20 to 30 years ahead on revolutionary military systems, meaning work underway today could yield operational aircraft by the 2040s. Several factors could accelerate this timeline. Geopolitical competition, particularly with China, has intensified focus on advanced military technologies. China has demonstrated remarkable progress in aerospace development, unveiling its own stealth fighters and hypersonic weapons in recent years. Additionally, the digital engineering revolution championed by Air Force leadership could significantly compress development timelines. Traditional fighter development from concept to production typically takes 20-plus years. Digital approaches have already demonstrated the potential to cut this timeline by half or more. The Air Force's experience with the Next Generation Air Dominance program provides evidence of this acceleration. When Will Roper announced in 2020 that a full-scale NGAD demonstrator had already flown, it shocked the defense community, which hadn't expected such a milestone for years. As one analyst noted, the development is certain to shock the defense community, which last saw the first flight of an experimental fighter during the battle for the Joint Strike Fighter contract 20 years ago. If similar secrecy surrounds 7th generation development, it's entirely possible that prototype testing is already more advanced than publicly acknowledged. The development of 7th generation fighters isn't merely about maintaining technological superiority. It's about preserving America's strategic position in an increasingly contested world. For decades, American air superiority has underpinned global stability and protected U.S. interests worldwide. This advantage has allowed American forces to operate with relative freedom, deterred potential adversaries, and reassured allies. However, this advantage is eroding as near-peer competitors develop increasingly sophisticated air defense systems and their own advanced aircraft. China's aviation industry has made remarkable progress, moving from producing licensed Soviet designs to developing indigenous stealth fighters in just 2 decades. Russia continues to advance its own aerospace capabilities despite economic constraints. Both nations are investing heavily in counter-stealth technologies and integrated air defense systems specifically designed to challenge American air superiority. Beyond traditional powers, the proliferation of advanced air defense systems to regional actors has created increasingly contested environments, even for 5th-generation aircraft. As these systems continue to evolve, maintaining the ability to project air power becomes increasingly challenging. The 7th-generation fighter represents America's answer to these converging challenges. An aircraft so advanced it can overcome even the most sophisticated defenses projected to exist mid-century. By maintaining this leading edge, the United States preserves not just military advantage, but strategic stability, as potential adversaries recognize they cannot achieve their objectives through military means. Developing revolutionary military technology never comes cheap, and 7th-generation fighters will undoubtedly require substantial investment. Current 5th-generation fighters like the F-35 have cost tens of billions to develop, with individual aircraft costing around $80 million each. 6th-generation fighters under the NGAD program are projected to cost up to $300 million per aircraft. By these metrics, 7th-generation fighters could represent an even larger investment. The question naturally arises, is this expense justified? The answer lies in understanding both the strategic value of air superiority and innovative acquisition approaches that could potentially reduce lifetime costs. Air superiority isn't merely a military advantage. It's a foundational capability that enables all other military operations. Without control of the air, ground forces become vulnerable, naval assets can be targeted, and an adversary can strike with impunity. The cost of losing air superiority would far exceed the investment required to maintain it. Furthermore, new acquisition strategies like the Digital Century Series approach could potentially transform the economics of fighter development. This approach emphasizes shorter production runs with more frequent technology refreshes, potentially reducing the massive sustainment costs that typically account for 70% of a fighter program's lifetime expense. As Will Roper explained, By applying digital manufacturing and development practices, we could drop the total life cycle cost of a next-gen fighter by 10% over 30 years compared to legacy fighters like the F-35 and F-15. Rather than sustaining increasingly expensive aging aircraft, this approach would see platforms replaced before they reach the point where maintenance costs skyrocket. While development and production costs would increase, modernization and sustainment costs would decrease dramatically, potentially resulting in lower overall program costs. The development of 7th-generation fighters will inevitably influence global military competition. Russia and China are already working on their own 6th-generation programs, and will certainly respond to American advances with their own initiatives. China's aerospace industry has demonstrated remarkable progress in recent decades. Having gone from producing licensed copies of Soviet designs to developing indigenous 5th-generation fighters like the J-20, China has shown both technical capability and strategic determination to match American air power. Chinese defense publications have already begun discussing concepts for what they call White Emperor, their potential 6th or 7th-generation fighter program. Russia, despite economic limitations, continues to invest in advanced aerospace technologies. Their PAKDP program aims to develop a 6th-generation fighter, building on technologies demonstrated in the Su-57. Russian defense officials have made clear their intention to maintain competitive air combat capabilities, regardless of cost. European nations are also advancing their own next-generation programs. The UK-led Tempest and the Franco-German Future Combat Air System, FCAS, aim to field advanced fighters in the 2040 timeframe. While currently characterized as 6th-generation programs, they will likely incorporate many technologies envisioned for 7th-generation aircraft. This competition doesn't necessarily represent a destructive arms race, however. The measured pace of fighter development, with generations typically spanning decades, allows for strategic stability despite ongoing advancement. Each nation pursues its security interests while maintaining deterrence relationships that have preserved major power peace for generations. The 7th-generation fighter, rather than disrupting this balance, would maintain America's position in an evolving competitive landscape. As 7th-generation fighters potentially move toward fully autonomous operation, a profound question emerges. What becomes of the fighter pilot, that iconic symbol of military aviation? The physiological realities of hypersonic flight present significant challenges for human pilots. The G-forces alone could exceed human tolerance, particularly during combat maneuvers. Add the complications of near-space operation and potential radiation exposure, and the case for removing humans from the cockpit becomes compelling from a purely technical perspective. AI systems have already demonstrated superior performance in simulated dogfights. In 2020, DARPA's Alpha dogfight trials pitted an AI system against a human F-16 pilot, with the AI winning decisively. The AI could execute perfect maneuvers without concern for G-forces and process information at machine speeds. However, military leaders recognize that human judgment remains essential for certain aspects of warfare. Ethical decisions, adaptation to unforeseen circumstances, and strategic thinking still benefit from human involvement. The likely evolution will be toward human-machine teaming, with pilots commanding groups of autonomous aircraft from safer positions. This concept builds on the loyal wingman programs already under development, where crewed fighters direct unmanned combat aircraft. Rather than elimination, the fighter pilot profession will transform, focusing less on physical flying skills and more on tactical command, ethical oversight, and strategic employment of autonomous systems. This represents not the end of the fighter pilot, but an evolution of a century-old tradition adapting to revolutionary technology. The path to a 7th-generation fighter presents numerous technical challenges. Developing materials capable of withstanding hypersonic temperatures, miniaturizing power systems for laser weapons, creating true autonomous combat AI, and integrating these revolutionary technologies into a functional aircraft all represent significant hurdles. However, American aerospace innovation has consistently overcome similar challenges throughout history. From breaking the sound barrier to developing stealth technology, the combination of national will, engineering talent, and strategic necessity has produced breakthroughs that once seemed impossible. The digital engineering revolution currently transforming aerospace development provides new tools to address these challenges. Virtual testing environments, AI-assisted design, and digital twins that can simulate performance before physical prototypes exist all accelerate the development process while reducing costs and risks. The 7th generation fighter program also creates opportunities beyond military applications. Technologies developed for these advanced aircraft will inevitably transfer to civil aviation, space exploration, and other sectors. Hypersonic materials research could enable faster commercial travel. AI systems developed for autonomous flight could improve air traffic management. Advanced manufacturing techniques could revolutionize production across industries. This process of technology transfer from military to civilian applications has historical precedent. Jet engines, composite materials, fly-by-wire controls, and numerous other technologies now common in commercial aviation began as military innovations. As we look toward the middle of this century, the development of 7th generation fighters represents America's commitment to maintaining the air superiority that has underwritten global security for decades. While much about these aircraft remains classified, the technology trends clearly point toward a revolutionary leap in capabilities. Hypersonic speed, space operations, directed energy weapons, autonomous systems, and revolutionary manufacturing will combine to create aircraft that might seem like science fiction today, but will become operational reality within the professional lifespans of pilots currently in training. The strategic necessity of these advanced fighters grows more apparent as potential adversaries accelerate their own aerospace capabilities and develop increasingly sophisticated defenses designed specifically to counter current American advantages. By investing in these technologies today, the United States ensures that tomorrow's Air Force pilots, whether in cockpits or command centers, will maintain the decisive edge that has been the cornerstone of American military strategy since World War II. The road to the 7th generation will require sustained commitment, innovative thinking, and substantial resources. But throughout American history, the nation has risen to similar challenges when national security demanded no less. The 7th generation fighter program continues this proud tradition of aerospace excellence in defense of freedom. If you found this information valuable, please support our channel by liking this video and subscribing for more in-depth coverage of America's military technology and strategic developments. Your engagement helps us continue bringing you the latest on the systems that keep our nation secure.